Welcome to EDU World Space.
For this question, we've been given a sample of size 17. The first two things we do is find two descriptive statistics, which are summation of xi, which is basically the sum of every term we have in our sample. And in our case, this comes to 530. I have it noted down here. The second descriptive statistic we find is summation of xi squared, which is basically every term in our sample squared, and then we add them. And that value for our sample here is 18,156. Now, using this formula for sample variance, we can find the sample variance for the given sample. Let's plug in the values we have. We have 1 divided by n here is 17, which is the sample size, so n minus 1. Summation of xi squared, 18,156. Summation of xi is 530, and we square it, and n here is 17. Upon simplification, you'll see that this value comes to 102.0294. This here is our sample variance. Now, now the second thing we do is find the critical values using using table G. The critical values are chi-square left and chi-square right values. Here I've written chi-square left is nothing but chi-square 1 minus alpha by 2 value, and chi-square right is chi-square alpha by 2 value. Now since we're finding a 95% confidence interval, alpha in our case is 0.05. My bad, let me just fix it, 0.05. The degrees of freedom we are dealing with here would be, since our sample size is 17, it's 17 minus 1 equals 16. So the degrees of freedom is 16. So chi-square left value is basically chi-square 1 minus alpha by 2. Alpha by 2 would be 0.025, and 1 minus alpha by 2 would be 0.975. Chi-square 0.9. So the chi-square left value is chi-square 0.975 with degrees of freedom 16. Using table G, you'll see that this value is 6.908. Chi-square right is basically chi-square alpha by 2. In this case, chi-square 0.025 with degrees of freedom 16. Using G table, you'll find that this value is 28.845. Now that we have the chi-square left and the chi-square right values, and we found the sample variance before, we can straight go to find the confidence interval for the sample variance. Oh, for the population variance. I have the formula written here. This is basically the formula to get the confidence interval for the population variance. This term over here is the lower boundary, and this term over here, oh, I'll just mark it with blue so that we can differentiate it. This term over here is the upper boundary. So let's calculate the lower boundary first, n minus 1. So here we have 17 minus 1 multiplied by the sample variance, which we found was 102.0294. 102.0294. Let's put this in a bracket too. Divided by the chi-square right value. Chi-square right we found was 28.845. Upon simplification, you'll see that this value comes to 56.5946. Just so we know that it's the lower boundary, I'm going to mark this in red as well because we marked it with red in the formula. Now let's find the upper boundary of our confidence interval. Using the formula, we have 17 minus 1 multiplied by the sample variance, which is 102.0294, divided by the chi-square left value, which we found was 6.908. 6.908. Upon simplification, you'll see that this value comes to 236, 236.3160. So here we found the confidence interval for our population variance. Let me just write it down in green. So our confidence interval for the population variance is 56. My bad. 56.5946. And the upper boundary is 236.31, oops, 3160. Now, this is the confidence interval for the variance. To get the confidence interval for the standard deviation, we just take the square root of the terms of the confidence interval for the variance. So the confidence interval for the standard deviation would be square root of 56.5946, comma, square root of 236.3160. Simplifying this, the lower boundary of our confidence interval for the standard deviation comes to 7.5229, and the upper boundary comes to 15.3726. 15.3726. This right here is our confidence interval for the standard deviation. I'm just gonna mark it in green with, my bad, with the standard deviation symbol sigma. And this over here, 56.5946, comma, 236.3160. This is the confidence interval for our population variance. I'm gonna mark this one as